Hello everyone, hope everyone is fine and doing good. So what is update? Well, update is this is gonna be the 7th video on kinematics video lecture series. In my previous video I just a little talked about the concept of U-turn. In this video we will talk about the concept of U-turn in detail, and we'll see how we can mathematically model the problem of U-turn in kinematics. So let's get started. Now let's start with acceleration. Acceleration, as we already know, that the time derivative of velocity of the moving particle, and if the particle is moving along one dimension, then we can say that acceleration is the time derivative of speed. So now let's take a look on this. We have acceleration is equal to dv by dt. This is the expression of instantaneous acceleration, and we already know average acceleration is written as delta v by delta t. Now, what is this delta v over here? This delta v is v2 minus v1, where v1 and v2 are the velocities of the moving object at different instants of time. Now, based on the value of this delta v, we have two possible cases. The first one is if suppose v2 is greater than v1, and the second case is case number 2, when v2 is less than v1. Okay, now let's take a look on each case one by one. Here, when we say v2 is greater than v1, then delta v comes out to be a positive quantity, because this delta v is equal to v2 minus v1. Similarly, if this comes out to be a positive quantity, then we can say acceleration is also a positive quantity. So when it is a positive quantity, then we call it as positive acceleration, and we also call it as acceleration. Now let's take a practical example to understand it. Suppose if any object is moving with speed v1, and after some time its speed becomes v2 in such a way that v2 is greater than v1. So that simply means there is some kind of acceleration must be there which is responsible for increasing velocity, right? So in that sense we can say acceleration should be along the direction of velocity. Okay, so this is the particular case when v2 is greater than v1. Now let's take a look on this particular case when v2 is less than v1. Now let's take a look on this particular case when v2 is less than v1. If it is the case, then we can say delta v is negative and acceleration is also negative, and we call it as retardation. So retardation means the object moves in such a way that its speed going to decrease as the time increases. Now the question is, what is the important condition of this? Important condition is acceleration and velocity must be in opposite direction. Okay. Now if it is the case, what happens? Now to understand it, let's take a very simple example. Now let's assume if this is any object which is having some mass m, and suppose someone has pushed it towards right, so it starts moving with speed v. Now after traveling some distance, let's assume this object reaches at this point b, and there is another person standing here. This person wants to stop this, so he needs to apply the force towards left. Okay, so because of this force there is acceleration acting on this block in left direction. So what will happen because of this acceleration? The speed of this object is going to decrease, and at certain instant of time it will stop. Now if the same acceleration keeps on acting on this, then this object will take a U-turn and it starts moving towards left, right? Okay, so this is the particular point at which the U-turn of this object takes place. Now What is the important concept here? The important concept is acceleration always tries to change velocity along its direction, right? So this is a very important concept here, which is very well applicable. Okay, so this is the case number 2. Now let's see how we can mathematically model the problems of U-turn in kinematics. When we say the mathematically model of a problem of U-turn in kinematics, then it simply means that how we are going to construct the problem of U-turn in kinematics. Now here, if we talk about the mathematically model of problem of U-turn in kinematics, then it can be done in 2 ways. What are these? The first one is polynomial relation between position of a moving object, let's assume it is x, and time t. So this is the first way. Now the second way to construct the problems of U-turn in kinematics is trigonometric relations. Particularly in this case, we have sine and cosine function. Okay, cosine functions between position of an object, this is x, and time t. So let's take a look on the way how we can construct the problem of U-turn in kinematics. Basically what we mean, how we can do the mathematically model of problems of U-turn in kinematics. Now let's discuss the first method of constructing the problem of U-turn in kinematics. It is the polynomial method. So if we take here 3 equations like x equal to 2t square plus 8, and assume the second equation is x equal to 2t square minus 8, and it is the third one. Now what I want to do next, I just want to find out the values of x for different instants of time for all these 3 cases. So let's do it one by one. Now let's draw a table. This is x, this is t. For time t equal to 0 it is 8. For 1 it is 10. For 2 it is 16. And for 3 it is 26, and so on, right? Now let's draw the table for the second equation. It is x, it is t. For time t equal to 0 it is minus 8. For time t equal to 1 it is minus 6. For time t equal to 3, not. For time t equal to 2 it is 0, right? And now for time t equal to 3 it is how much? It is plus 10, right? Okay, now let's take one more value, time t equal to 4. It comes out to be how much? It comes out to be 26, right? Okay, now what about this? Let's draw the table for this case as well. It is x, it is t. For time t equal to 0 the value is 0. For time t equal to 1 it is minus 6. For time t equal to 2 it is how much? So it is, let's plug in the value over here, 2 into 2 square minus 8 into 2. So it is how much? It is 8 minus 16. So it is how much? It is minus 8, right? Now let's plug in the value time t equal to 3. So for 3 it is 2 into 9 minus 8 into 3. So it is how much? It is 18 minus 24. So the value is minus 6 at time t equal to 3. At time t equal to 4, let's calculate it over here. So it is 2 into 4 square minus 8 into 4. So it is how much? It is 32 minus 32. So it is 0. And let's take one more value, time t equal to 5. So if we plug in the value of time t equal to 5 over here, then it is 50, and it is how much? 8 into 5. So the value is plus 10. Okay, so these are the values of x for different instants of time in all these three cases. Now what I want to do, I just want to draw these tables on a number line. So let's do it very quickly. Suppose this is what the x values. So here let's assume it is 8, it is 10, 16, 26, and the instant is time t equal to 0. This is 1, 2, 3. Similarly, if we draw the number lines for this particular case, here it is minus 8, minus 6, 0, 10, 26. It is what time t equal to 0. It is 1, 2, 3, 4. Okay. Now let's draw the same thing for this equation. So here this is 0, minus 6. Okay, if I'm representing these numbers on number line, I should go in the negative direction, right? So I should take x equal to 0 over here, and it is minus 6, it is minus 8, and it is plus 10. Okay, now let's try to understand what is going on in all these three cases. So if we see over here, then we can say the object is moving in right direction for whatever be the value of time over here. Okay, now the same thing is here, the object is moving in right direction, right? Now if we see this number line very carefully, then we can say that if the object starts from here, then it first moves in this direction, and then it takes U-turn and moves in right direction, right? So this is the particular case in which we are really interested in. Now let's take a look on all these three equations in x and t. If we talk about this particular equation, then we can say the position of the object increases for all the time, and it is the same thing which happens over here. If we notice this minus 6 is greater than minus 8, and this 0 is greater than minus 6, so it is going to be the case of increasing distance with respect to the time. Now if we take a look over this table over here, then we can say the position of the object first decreases and then it increases with respect to the time. Now in order to have this situation, we must have following points in our mind. Let's see what are these. The first point is polynomial function should be higher in t in time t greater than 1. Okay, and generally we deal with the quadratic polynomial. So the second point is about the quadratic polynomial. Quadratic polynomial must have, or we can say the quadratic function must have linear term in time t. And the third point is sine of quadratic term and sine of linear term must be opposite. Okay, so these are the three important points which we should keep in our mind while dealing with the problem of U-turn. Now by keeping these three important points in our mind, let's take a look on all these three equations. Now the first question is it the case of U-turn? will the particle take reverse of its direction at certain instant of time? Now you can say it is not. Why? Yeah, it is quadratic, but it doesn't contain any linear term, right? So this is not the case of U-turn. Okay, what about this? This is also not the case of U-turn. Now, what about this? You can say definitely the particle is going to take U-turn over here. Okay, so these are the three important points. Now, as we already know that if object moves in one dimension, then distance is always equal to displacement. And the same thing about average velocity and average speed. So if I talk about the distance and displacement, so they must be equal in these two particular case, right? So now let's take a look on this question. Calculate distance and displacement. Let's take one more question over here. Average speed and average velocity. Okay, and let's take third one also, instantaneous velocity and speed. We have already seen how we calculate the basic parameters for the motion of an object moving along a straight line without taking any U-turn. So we can solve for these parameters for these two equations by just substituting the value of time t for different instant of time and then just carrying out the necessary calculation. Now, what about this? For this particular problem, when the object takes U-turn, then we have some important steps. So let's take a look on these. So the point number 1, calculate time t0 at which velocity of the object is equal to 0, and it can be done by taking the derivative of x with respect to time t and equating it equal to 0. Okay, now from here we will be getting the value of time, and that will give us the information about at which instant of time the particle takes U-turn. Okay, now sometimes you can get the negative value of time. So if it happens with you, then you can say the particle is not going to take any U-turn. Okay, so this is the point number 1. Now the second point is calculate x for this time t0, and the third step is calculate x for time t, and the last step is calculate x for time t equal to 0. Okay, and after that we need to take the necessary calculation. Now let's take a look on how we can solve this particular problem by just keeping all these steps in mind. Now we have problem x is equal to 2t square minus 8t, and the first question is find out distance and displacement. The second question is what is speed and velocity. The third question is what is instantaneous speed and instantaneous velocity. So basically we have to find out all these for time equal to 10 seconds. Okay, now what is the first step? The first step is we have to find out the time at which the velocity of the object is equal to 0. Now we already know if we have given the position time relation, then we can take the derivative of this x, and we can do it in this way. So this is what dx over dt, so it will give me 4t minus 8, right? And if I put this term equal to 0, then I can say 4t minus 8 is equal to 0. And from here, I can calculate the value of time t. So it will give me 8 upon 4 equal to, that is 2 second. So that's mean at time t equal to 2 second, the speed of the particle becomes 0. And after that, the particle will take U-turn. Okay. So this is the first step. Now let's take this is t naught. Now plug in this value t naught over here, find out the corresponding value of x. So x is equal to how much? So this is let's suppose it is x naught, and it is 2 square minus 8 into 2. So if we solve it, then it will give minus 8 meter. Okay, so this is the position of the object at time t equal to 2 second. Now the next step is, what is the position of the object at time t equal to 10 second. Okay, so for this we can say for time t equal to 10 second, x is equal to how much? X is equal to, that is okay, let's substitute this value over here. This is 8 into 10, and it will give me 200 minus 80. So x10 comes out to be 120 meter. Okay, now what is the third step? Third step is we have to find out the x value at time t equal to 0. So if we plug in the value of time t equal to 0 over here, then position is what? That is 0. Okay, now we have done all the steps. So what we can do now, we can draw the number line. Okay, so this is what position 0 at time t equal to 0, and time t equal to 2 second, the position of the object is how much? That is minus 8. So I need to go in reverse direction, right? So this is what let's take a point, this point over here, and it is minus 8. After that, what will happen? We will plot this position 120 meter. So let's assume this is the position 120 meter over here, and this is the location of the particle at time t equal to 10 second. Okay, so this is time t equal to 10 second. So what is the path taken by the particle? Now first the particle moves towards left, and then it comes at halt. After that it starts moving towards right. Okay, so this is the path taken by the particle. Now if we take this path very carefully, then we can determine within which region the motion of the particle is accelerated, and within which period of time it is going to be accelerated. Now if we recall our discussion, then we already know that if acceleration and velocity are in opposite direction, then it is going to be retarded motion, right? So if we take a look over here, particle is moving towards left with decreasing speed, right? Because only then the particle can come in rest position. Okay, so that's mean acceleration is along positive direction and velocity is along negative direction. So between time t equal to 0 and time t equal to, what is this position? Actually it is how much? It is 2 second, right? So time t equal to 0 and time t equal to 2 second. For this period of time, the motion is retarded, or we can say retardation. Okay, and after that, from time t equal to 2 to time t equal to 10 second, the motion is accelerated motion. Why? Because after time t equal to 2 seconds, both velocity and acceleration are in same direction. Okay, so this is the particular case when we are going to determine the types of motion. Now, based on the path of this particle, we can determine what is the distance and displacement. So distance is equal to how much? This is 8. It will be counted twice. Okay, so this is 8 plus 8 plus 120. So this value comes out to be 136 meter, and displacement is equal to 120 meter, right? Now, based on this value, distance, I can calculate speed. So speed is equal to what? Total distance upon total time. Basically it is what? It is the average speed, right? So the total distance is 136 and it is divided by 10, so it will give me 13.6 meter per second. Now what about the velocity? Velocity is equal to 120 upon 10, so it is 12 meter per second. Now the next question is about the instantaneous speed and instantaneous velocity. So for this we can use this expression over here. So this dx by dt is equal to 4t minus 8, and if we plug in the value of time t equal to 10 seconds, it will give 32 meter per second. Now the question is, what is this value? It represents both. Why? Because as the name suggests that it is the instantaneous value of speed and velocity, so they must be same. Okay, because we want to find out what is the value of speed and velocity at this particular instant of time. So that's why these values are same. Okay, now this is the time to discuss the second method of mathematically model of problems of U-turn in kinematics. So now let's discuss. Now the second method is trigonometric function of time t. Particularly here we talk about sine or cosine function. Now let's take a look on this. X is equal to 4 sine 30t, and if we make a table of this, then it looks like this. X t, time t equal to 0, x is 0, time t equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So when we put time t equal to 1, it becomes 30. So sine 30 is how much? It is 1 by 2. So we will be having 2. And if I put time t equal to 2, this will become 60, and sine 60 is under root 3 upon 2, and it is 2 under root 3. And at t equal to 3, it becomes 90. So I will be getting 4. And after that, if I plug in the value time t equal to 4, it becomes 120, and it will give me again 2 under root 3. For 5 it will give me 2, and for 6 it becomes 180 degree, and this value becomes 0. Okay, now if I keeps on putting all these value, then I will be getting the value like this. So this is minus 2 under root 3, minus 4, 2 under root 3, minus 2, and finally it will be 0. Okay, now let's try to plot all these values on number line. So let's take this time t equal to 0. The position is 0, right? So this is 0 at time t equal to 0, and the next point is 2. This is 2 under root 3. This is 4. Okay, and we can draw the negative values as well. So this is minus 2 under root 3 and this is minus 4. So if you see this table and this number line very carefully, then it the particle will move like this. Okay, so what is going on here? The particle is taking U-turn repeatedly, right? So this is the particular case, but this is something called the simple harmonic motion. So I restrict myself about this method up to this point only, because we have the separate chapter of simple harmonic motion and we will discuss it later in videos. So this is about trigonometric method. Okay, now this is the time to discuss the solution of the question which I asked in my previous video. The question which I mentioned in my previous video, that was the relation between x and t, and the relation is 2t square minus 12t, and we have to find out distance and displacement at time t equal to 10 second. And the second part of this question is we have to find out speed and velocity for time interval t equal to 10 second. Basically in this part we have to find out the average value of speed and velocity. Now we are in the stage of identifying whether the problem belongs to the case of U-turn or not. Now if you take it here, then we can say this is going to be the case of U-turn, right? So now let's solve this. So the first step is to find out the time t naught at which dx by dt is going to be 0. So if we take the time derivative of this expression over here, then we will be getting this is 4t minus 12, that is equal to 0. So it gives us time t equal to 3 seconds, right? So at this particular time, the speed of the moving object becomes 0. Now the next task is to find out x at this t. So if we plug in the value of time t equal to 3 over here, so it comes out to be, this is 18 minus 36, so this is minus 18 meter. Now the next step is to find out the value of x at time t equal to 10 second. So it will give, this is 200 minus 120 and it is 80 meter. Okay, now the third step is to find out x at time t equal to 0. So this value comes out to be 0. Now let's plot the number line over here. So this is x equal to 0 and time t equal to 0. At time t equal to 3 second, the position of the object is minus 18. So this is minus 18 meter, and at time t equal to 10 second, the position is how much? This is 80 meter. Okay. So the path of the particle is like this, right? Now based on this path, we can calculate the distance is equal to 18 plus 18 plus 80. So it comes out to be 116 meter, and the displacement is equal to 80 meter. Similarly, we can find out the average speed. Speed is equal to 116 divided by 10. So this is 11.6 meter per second. And the velocity comes out to be, that is 80 over 10. So it is 8 meter per second. So this is the solution of the problem. So that's all for today, and if you have any question, then you can comment me in the comment box. I will definitely reply back to you. So see you soon in my next video. So keep watching and stay connected for further updates.